Hello everyone. So we might start our third technical session. In this session we are going to have two presentations from the projects selected in the European coordinated call with Brazil. We have this kind of collaboration with NSF, also with the European Commission. So with the European Commission we launched it in the last year, last 2016, the third coordinated call, and in 2017 the fourth coordinated call. So there are 11 projects in cooperation with the European Union. One of them is Secure Cloud, which will be presented here by Professor Christoph Fetzer from the Technische Universität Dresden. Secure Cloud stands for Secure Big Data Processing in Encrypted Cloud. So please, Christoph.
Thank you. Thank you for the introduction. Can you hear me? Do I need to closer? Okay. So I have the pleasure to present Secure Cloud. It's a 3-year EU-Brazilian research project. We are the last year now, and let me start by going forward. Yes, it's not working now. Let me try the video. Is that better? Yes. Wow. I stand now on this side. So we have 14 partners in the project, 7 from EU and EU associate countries, and 7 partners from Brazil. And I'm the European coordinator, and I have the pleasure to coordinate the European partners and the Brazilian. We meet regularly and also exchange students, of course, to ensure that we have common research papers. And let me start by talking about our objective. So, Secure Cloud, as the name says, it's about cloud computing, secure cloud computing. What do we mean by that? We have something that we call application-oriented security. So we want to make sure that if I am an application service provider, I have an application and I want to run that in a cloud and protect the confidentiality and the integrity of my application. So I want to protect my data, that the data doesn't leak, nor is it modified such that I do not detect it. So whenever there is a modification of my data, I should be able to detect this modification. And we have always some attackers, and we assume a very powerful attacker, like an attacker that might have root access on the machines that I'm computing. So that means traditional access control will not work. For example, that might be a system administrator that might be paid by somebody who is interested in my data. So that is a common way of getting to somebody's data by just spending some money on some system administrators root access. And so what we want to have is that my data is protected, my computation is protected, and my communication. And actually what is not on the slide, also my code should be protected. So if I write in, say, Python or in Java, it's really easy to reverse engineer the code, and often my IP is in there, so I also want to protect the code of my application. And so here, for just an example, I might have some code, if I'm a service provider, that has some volumes, so has some data somewhere stored in disk. I have some service that runs, it might be one service, might be multiple microservices, and the service will get some data from volumes, and it will also communicate to some clients. And what we want to make sure is that the data stored on disk is protected against this powerful attacker. My data stored in the service is protected, and I want to remind you, as soon as I have root access and your application runs on that machine, I can just dump the memory and get all your keys that you might use to encrypt your data on disk. So if I as a bad guy have root access, I'm really powerful and get all your data that you have. And so we want to protect against that threat because we want to support applications can run in an unsecure environment. That's good for cloud computing, but also for IoT. This is really interesting. And so let me abstract away from from all the other things and just focus on a single cloud server where I want to run my application. And to protect against the root attacker that can just dump my memory, what we do is we execute all services in trusted execution environments. So there's some recent CPU extensions by Intel that's called Intel SGX, and what we do in a nutshell is we make it really easy for you to use Intel SGX and some upcoming CPU extensions by other CPU manufacturers. So we want to make sure that you can take your application code and without code changes, we want to permit you to run your code in this trusted execution environment with a reasonable performance overhead. The only thing that you have to do as a service provider is to have to define some security policies, and we even help you with that, so that you can move your application into the cloud with minimal overhead. And the reason for the minimal overhead is because security, most of the service provider, they see it as an afterthought. They don't want to spend time on that. They don't see that there's a direct return of investment, but of course they have to protect their application, and we want to make it as simple as possible to provide it by no source code changes. So you can continue your standard development process. You download some source code, you customize that a little bit, and we help you to make it as secure as possible. And so this was kind of the general introduction. So you've seen that there are 14 partners, so there's lots of work going on during the duration of 3 years. So I will focus the remaining slides on some part project or some sub-project that is actually between TU Dresden and UFCG, so Andres Brito's group who sits there. And so I want to kind of briefly give you a very simple use case and show you that even for that simple use case, we have lots of complexity that we have to solve in our framework. And then I want to show you that this complexity we can hide from the user by making it really simple to use. And so let me try a very realistic use case. So we actually have commercial customers that want to use that. So I am a customer and I have some data, and that might be on my trusted server. It might be still encrypted by the operating system. There's access control. But what I want to use do as a user, I want to ship my data to a cloud. I want to make sure that it is never in plain text. It's always encrypted. When I move it over, it should a one-to-one copy of my data should be on an untrusted cloud server. My service should now run in encrypted fashion so that my data is never visible in plain text, and also the keys to protect all that data should never be visible. And the application that I might use might be sitting on Docker Hub. So these days, most of the cloud application, they use container technologies from Docker. So there might be, I have an image that I use from Docker Hub, and that Docker Hub is untrusted in our case. So we don't trust that actually the image that we store there is not manipulated by Docker or some other people with access rights. Okay, so this is kind of the context. We want to move our application. Instead of running it here, we want to run it somewhere there, and suddenly everything gets encrypted. And we want to make sure that this attacker, if the attacker sits outside, cannot read the encrypted data, so cannot get the keys, cannot read the data that I store in my main memory, or even if that is a root or attacker with root access, cannot read the memory either. So we want to really protect the data and the computation. And to do that, I also have to trust somehow my programs that run there. And so let me, in the next slides, introduce some of the problems that we have to deal with. And I have, I think, 20 minutes. You tell me when I'm running out of time, please. Because I forgot my stopwatch here, sorry. So we have this container image, and that kind of contains the code that we want to run here in our service. And if I'm an attacker now I always take the role of the bad guy. If I'm the attacker and you run that service, what I could do if I have access to that container image, I might manipulate that so that my code is running there or my data is there. Or if Docker is really good and protects against my access, maybe if I have root access on this machine, what I can do is you download that image. If you're the client, the good guy, I can actually change that on the machine and change that image so that I'm as a bad guy in control of your service. So we have to protect our service that it runs the right code. And also I have to protect that all the keys that are in the service are not leaking in some way, because if I as a bad guy get these keys, I can actually do all kinds of things with it. And so when I give that presentation, people say, well, we have already a solution. We just sign that container image there and everything is good. Because then the image creator has certified that there's the right code and nothing bad can happen. But I just want to remind you that if or if you have that signature, signed images, this is good, because if your container engine, so the Docker engine typically, is not manipulated, it will actually reject all bad images, which is good. So you should always do that. But of course, I am, as a creative attacker, what can I do? I either get a hold of the image creator's key, which is not too difficult because that sits on some laptop, that it might be badly protected. Or if I have root access, I might change the Docker engine. So I just want to give you some ideas what I, as a really powerful attacker, can do to change the code that you are running. And want to convince you with that we have to have some new way, and I want to show in the next slides how we address that in the secure cloud context. And so what we do is we describe application the following way. We say we have this image, and what it contains is some process, some service that runs, and we want to identify that with a unique hash, this service. And also we have a file system that runs there, or that is stored there, and we want to make sure that this file system is protected against attacks that change the integrity, so modify the file system, and also ensure the confidentiality. So that therefore when we describe an image, we internally use some more description to describe the process, where we use terminology of Intel, which is called Mr. Enclave, that is a hash over that process that should be running there. And we have a file system that is described by a tag that's kind of a hash, or the root hash of a Merkle tree that describes that file system in a nutshell, and some key that we have there. And so what we now do is, if I'm now change the role, I'm now a good guy, I'm an image creator, so I create some service that you might want to run. I say, my process, if you want to run that, has this Mr. Enclave. So if you want to, you should only run that process if it has this hash. And my file system has a certain tag, so you should only trust my image if it has a certain state. And then I as a client might not completely trust the image creator. I might partly trust it, but not completely. And so I want to tell you that in real life, it's not black and white in the sense that you cannot completely trust somebody. So, but what we have typically is a rely but verify approach. So we rely on the image provider, but we verify that maybe by having some security team that additionally checks that process in the file system, that it does what it's supposed to do. And then I, as a client, want to make sure that whatever was verified by the security team is actually running on my behalf as a client. there the problem doesn't stop, so I want to continue to show you that there is some complexity by, even for such a simple problem of moving the service into an untrusted host. And if I'm now taking the role of a client that uses that image or that process, I also have to provide it with input data. So like I have some data that should be mined by that process, and I want to have some output data too that should be protected because my intellectual property is in there. And so therefore, I, as a client, provide input files, and I want to get output files back, and that should be protected. And it should be protected in such a way that neither the image creator that provides me with the code should not be able to read my data, because that's not this image creator's business. Also, another client, they should keep their data for themselves, and they shouldn't look at my data. And of course, the attacker, the bad guy, should also keep out. So we have kind of a multi-parties, and we should keep track of all these parties and make it still as simple as possible for the client to use that system. And so what we do is, oh, no, I forgot one more point. If I'm the image creator, I have also intellectual property in there, and I want to protect that from all my clients. So they shouldn't see my intellectual property either, because they just copy that and then they don't pay me anymore. So there, what I'm saying is there is some trust and mistrust, and also protection of intellectual property that we have to do. Thank you. And so how do we select that? How do we address that? What we have is kind of security policy that can be combined. If I'm an image provider, and there's lots of complexity on the slide, sorry for that. If I'm an image provider, I can say, I can give you access to my image, my file system, but in such a way that you can execute it, but you cannot read the content. And to do that, I kind of can export some keys, if you're now a service provider, in an opaque way to your security policy. Say, you can access my file system as long as you run my process, but only then you can access my file system. And I, as a client, I can define a security policy that says, I give that process access to my volumes, but only to that process. And so that means I can kind of pass secrets out in such a way that my data can be read, but only to a certain process that has a certain Mr. Enclave, and it runs in a certain file system context. So that means what we need to have is some way to ensure that when a process runs, it's actually that process with a certain Mr. Enclave, with a file system, and you see there's some complexity that needs to be solved. And so what we have is in our secure cloud platform, we have a system that's called a configuration attestation service that takes all these security policy and processes them and makes sure that everybody can keep their secrets secret, and it keeps all that secrets also in enclave, so you can configure it that secrets never leak out of these trusted execution environments. Ease of use. If you like command line arguments, it's really easy to use. So CLI, so if you use Docker, you have a certain Docker CLI, and what we provide you is something very simple, similar to Docker command line interface, so you can run your service just on a remote host. You give it some image that you want to run on which host, and you give it some volumes locally, and it will all be encrypted, pushed over. Keys will be given to the process, and everything is done transparently for you. You have to trust the security policy. From a summary, we have, it's a 3-year project, so EU always likes to commercialize things, so it's kind of research plus innovation project. So we have parts of the platform is already commercialized before the end of the project. We have, so the Scone platform in particular, we have already customers in the health domain that use the platform. Also blockchain use cases, there is a commercial one, there are some more coming. We are also very well published. We have an OSDI paper, Usenix ATC twice. We have Eurosys, also Best Paper Award, and SOSA. So we have quite a few papers as well as commercial impact. And that was my 18 minutes. Thank you very much.
Great. Great. Thank you, Christoph. Is there any question from the audience?
Congratulations. If you use slice as a service, you changed something in your project?
Sorry?
If you use slice as a service in the cloud,
Yeah.
your proposal security changed something?
I don't hear acoustically what you're saying, so.
If you use slice as a service,
Yes.
if you consider slice as a service in your cloud, your one cloud are offered slice as a service. Okay? Your proposal will be changed, is necessary change or not?
I think it's not changing.
Yeah, okay. Is there any other question? I just have one question. Don't run. Last
Thought
question. That's okay. I mean, this question is how we always ask this question for security solutions.
Sure.
What is the impact on performance? Because I know the project and I know that you use a special kind of processor.
Yes.
And which is Intel Special Edition.
Yes.
And you have above that you still have many phases and many things you do to protect the Docker and protect the processes.
So performance depends on the application. So that is a very generic answer, I know. So we have some performance measurements also on the website. There's a website down there. You can see also from Andre's group some measurements for Python. And the Python, let me give you the positive answer first. And so if you look at Python, if you run your application in interpreted Python, so the standard C Python, and you go to Scone or the secure cloud platform and use just-in-time compilation, you gain speed. So you have actually acceleration if you go to our platform and do just-in-time compilation. So you go back, you can kind of make more speed by doing just the right thing and also doing security and just-in-time. If you look at kind of large data processing, so one of the problems that you have in Intel SGX is that they have some internal caching that is very small right now on the CPU, and that can cost lots of performance. But if you look something like Spark stream processing, so we have Spark running inside of these enclaves, and there you have so many other overheads that in total you get a 20% overhead in standard benchmarks for Spark. But if you have a large database like MySQL and you have lots of data and you gain lots of speed up by having a large memory in the native execution, then your performance will be not that good if you go to enclaves and having this small cache in the CPU. But that might change, so Intel will improve on their performance, and then also for these workloads you might not have too much of a overhead. Maybe I would hope 20% in the end.
That's fine. Thank you. So now we're going to have the presentation of Atmosphere. Atmosphere was selected in the last Brazil-Europe call, European Union call, and Atmosphere stands for Adaptive, Trustworthy, Manageable, Orchestrable, Secure, Private, Assuring, Hybrid Ecosystem for Resilient Cloud Computing. Yeah, Atmosphere. So please,
sorry for that.
Andre Brito from Federal University of Campina Grande. For
So hi everyone. I think now it's working correct. So it's a pleasure to be here. Thank you, Anderson, for the presentation and for pronouncing the unpronounceable name of the project. So I'm going to talk a bit about the maybe no. Okay, should be better now, right? So my presentation will be much of a higher view than what Christoph just presented. In the Atmosphere project, we want to create a framework that allows you to build applications that run distributed, so very distributed in a federation of cloud environments. And besides this hybrid federated platform, we also want to provide some services that will make the life of the developer easier, such as monitoring services, execution services, storage services, and so on. I'm going to give you a couple of details, but if you look here in this, so if you look here into this stack, so based on these two layers, what you will have is a collection of cloud resources hosted by different clouds. So for example, Amazon, for example, OpenStack private clouds, OpenNebula private clouds, CloudStack clouds, VMware, also because there is a partner. And on top of that, you want to build storage services, so data management services that are also secure, so that you can give sensitive data to these clouds without having to worry about who could steal your data, as Christoph just told you. And then on top of that, you want to have data processing services that are built using the technology such as the one Christoph just showed you. And then on top of it, you have applications. In our case, we use the medical imaging domain. And as you know, so medical applications typically have a lot of sensitive data that you don't want to leak. Okay, so to give you an example, a concrete problem, let's consider this. So you want to build a classifier for data that is sensitive. So you want to train this classifier, and you are using sensitive data for that. Once the model is trained, you also want to use it to classify data from users. And the data that the users are submitting to your service is also sensitive, right? So that's the goal of the project. And besides that, you want to do things like that without having to worry with infrastructure, resources, scheduling, access control, and a lot of other things. So that's where the two first levels come in. So, and then, so there are a lot of keywords in the title, and they're all about trust. So, and trust is a very broad concept. So trust depends on many things. So trust depends on your past experience. Trust is difficult to earn and easy to lose. And trusting a service, a computing service, is as difficult as trusting in people, because you need a lot of evidence over time that you can give sensitive data so that you can trust your critical application to the cloud environment. And then, because of that, we take a multi keyword aspect, so we considered a broad spectrum of properties, and these are mentioned here. So for example, we consider security and privacy. So secure, you don't want your application to be changed. You don't want malware to be infiltrated in the services that you are deploying. You don't want to lose the control of the data. You don't want to see different kinds of services in different points of the federation, because then at the end you could not use any place in the federation. You could not deploy your application in a broad geographic environment. You want to be aware of isolation and stability metrics for your application. You want to see that your classifiers, they are fair and they provide transparency. So that means that you can detect when they're biased in classifying the data. And you can also see whether the decisions that they took were based on the right data to consider, or you can track how one piece of data was used throughout the workflow. So these are features that you also want to have when you build a critical application that considers sensitive data. And finally, you want your application to be always running. You want dependability to make sure that your services are available to the users when they need it. And to achieve this kind of properties, you need to measure. And you need to measure not only in runtime, but you need to have metrics that you compute on design time. And this is shown here at this figure. So you have a cycle here that while you're building the application, you collect metrics, you check vulnerabilities, you check performance. And once you are happy with it and you want to deploy, you want to keep monitoring, because maybe availability will go down, maybe security and privacy will go down as vulnerabilities appear. So you want to keep monitoring the applications, and you want to compute scores for the metrics that I mentioned, and if something goes wrong, you want to adapt and you want to change your running application. So this is one of the concepts from the project, which is the monitoring and adaptation service. And then, as I said, it goes through all layers. And one of the layers is the federated environment, where you use a system that we named Fogbow. And it was the result of a previous project. And Fogbow provides a single API for you to instantiate resources. So you could have your VMware cloud, you could have your OpenStack cloud, you could have use your Amazon account, but you want to create resources in the same way. You don't want to have one script for each environment. And then Fogbow runs in a site and federate all these clouds, all these resources, so that you can simplify the life of the application deployer. Then, as I said, on top of that, you want to build data management services. And in this case, I'm simplifying here with use case where the data management service is composed of a module that intercepts access to the database. And this module should run in a trusted environment, so that this module could do the checking on the policies, decrypt only for those who should have access, and then maybe give only the data if the application is the application that is supposed to get access to the data. You don't only need to have credentials, but you need to have the right application running at the right environment, so that you can have access to the data that someone gave you. And with an engine running inside a trusted environment, then you can also imagine that you can do a lot of things. Not only things based on authentication and access policies, but also things that would process the data to transform it so that you can preserve anonymity. So, for example, you could remove data from queries, you could aggregate data from queries, just to make sure that you don't lose control of the data for applications that should not have access. And here I have an example of one demonstrator that we will give at the end of the project. It's not my time, right?
No.
Okay. At the end of the first year of the project, so we're almost there. And in this workflow, what you can see here, so you don't need to worry about this with these small letters, but the idea here is that you have a data owner that will get a data set, push it to a storage backend, and for example, we considered several storage backends such as replicated, sharded, multi-cloud, MongoDB, or an interplanetary file system, which is a peer-to-peer file system. And when this guy uploads his data using the client, what he does is that he encrypts the data locally, so that this data that's now in the cloud, so I think the data that's now in the cloud is, even if it's stolen, it's encrypted. And in this process, the user also registers the hash of the data set, for example, in a blockchain, so that later, if someone wants to use that data, you could use, for example, the blockchain to track provenance, or to have transparency on what result was computed from which data input data sets, and can be, maybe you can also be compensated for having your data used. And then once the data is stored on the storage backend, and the blockchain contract has your data set hashes and the conditions to use your data set, then you would go to that secret management service that Christoph mentioned, and you would store the encryption keys for your data. And you also would condition the access to that encryption keys for specific applications that you know you can trust because someone else vetted that for you, or because you know the source code and you have the hashes of the source code or hashes of the code that will process the application, and you know that they will not leak the data. And once you have that, you could have a processing service that would ensure things like security and transparency. First, because it would only have access to the data if it runs inside an XGX environment. So there's the security. And in the same line, you can also use an execution platform that enforces that even if the correct application is trying to access your data, this application will only have access to the data after the usage is consolidated in a blockchain, for example. And then with such a simple structure, you could have at the same time security and transparency, which is a good example of the things that we are trying to do in the platform. So in our application example, so you would have data that is sensitive, that was used inside an enclave to train a model. The model has a track record for all the data sets that were used to train that model, and no human has ever seen the keys, no human has ever seen the data. Okay? And then just to give a quick summary, if you're looking for something in Atmosphere, we created several personas. And for example, if you're an application developer, what kind of things you would be interested in this tool set? And I would say that the most interesting things we have right now are the trustworthiness scores, so that you can evaluate how trustworthy is your application and how trustworthy is your application running right now. So you would have the security guarantees, because if you're developing an IoT application and people is submitting sensitive data to you, you also get afraid of losing the control of that data, right? So it's a huge responsibility to have sensitive data from other people. And if you have tools that keep this data secure, it's a good benefit for you. And finally, as Christoph also mentioned, you maybe want to protect your own creation. So you have an application, maybe your code, maybe your libraries will run in someone else's infrastructure, and you don't want to lose control of your property. If you're an application developer, application manager, so you deploy the applications, then one nice thing is that you have an environment that is composed of multiple clouds that can be accessed in a very transparent way, so that you can increase the amount of resources that you have at your hand, or the diversity of resources that you have in your hand, so increasing also availability. So this, as I said, the cloud orchestrator will abstract which cloud orchestration platform you're using below it, and also provide a lot of metrics for you to track your application. And then finally, if you're a data scientist, we leverage data analysis frameworks also from previous projects, and improve this framework so that they consider metrics and scores such as fairness, explainability, transparency, and also privacy, so that you can do processing on critical data without having to worry too much about how this is implemented on the low level. So the Atmosphere project leverages from several previous EU projects. So the Fogbow comes from the EU Brazil Cloud Connect project, was from the second call. It uses the data analysis framework from the Pixie project, also from the third call. It uses the mostly foundations for secure processing, like Christoph explained it, from the secure cloud project from the third cloud, the third call, and also inherits a lot of dissemination events and marketplaces that were generated by the cloud forum project, also from the third call. So I hope this very high level presentation has been somehow useful. There are a lot of papers and documents in the website. You just Google for Atmosphere, EU Brazil, and you get it. Thank you.
Thank you. So thank you for the presentation. Is there any question from the audience?
Hi. Can you hear me?
It's great.
Okay. Thank you very much for your presentation. It was very interesting. I have a question. Both your and Christoph's presentation, you talked about using Intel SGX extension. And I was wondering if a client, or how can I'm having trouble wording this right, but is Atmosphere compatible with, let's say, AMD's SGE, or, I'm sorry, just
so you mean the other trusted execution environments?
Yes,
kind of
exactly,
right.
exactly.
So as Christoph said, oh, yes, please continue.
I was just wondering if it's compatible, if I have like an Epic server, if I can use Atmosphere, if it's going to be compatible.
So right now, for example, I believe Christoph even mentioned that today we support Intel SGX. I don't know if he mentioned that we did look into AMD, and the security guarantees are not, right now, they're not comparable to Intel SGX. So in its secure cloud project, if you want to add something.
So the architecture principle is independent of SGX. So the architecture of that we develop in secure cloud is independent of SGX, and we would like to support multiple secure architectures. We looked at AMD. AMD has big gaping holes in their security model. So right now we do not support AMD. They might fix that and then we will support it. So we have internally a compiler-based approach. So the technology independent. So what we can do is just provide a new compiler path for the different technology, and then we can support different CPUs by just kind of replacing the compiler. So that means eventually, if we have enough resources, and we might also, when AMD fixes their security bugs, we will support also.
Yeah. So the basic constructs are the capability of attestating remote applications, the capability of processing data that is encrypted in memory, and that's basically what everyone wants to provide. So trust zone, AMD, ARM trust zone, AMD, Intel, and so on.
Okay, thank you. It's more of a curiosity.
And now that you mentioned, there is the pyspeed.lsd.ufcg.edu.br that you can check. There is a graph there with the comparison benchmarks for Python. It's a
question. Okay. That's a great question. I just noted that question here, so you made it. I'm happy with that. So thank you very much. We're now going to proceed to we're going now to proceed to the pitch session. Well, this international cooperation always have a previous phase in which we decide, Brazilian government and the European government or NSF they decide what will be the topics of the calls. And one of the most important inputs in these meetings are the outcome of some workshops like this one. So today we have these speech sessions so that we can hear from the researchers in this area what are they proposing for future cooperation calls. So they can come here and explain, for example, about the project that they are working on, about the area that they are working on, and we can take these presentations to these meetings between the Brazilian government and the foreign agencies. So to start this speech session, I will invite Professor Marinho Vila Barcelos from Federal University of Rio Grande do Sul.
Thank you so much, Anderson. Hi again. So I'm gonna touch just two main points, and they are in the scope of network security. So our context is that Brazil is a very large and important country. It represents the 8th largest economy in the world, considering the PPP, which is the well, this data has been compiled recently, I think by CA, but it's a proportional purchase, something like that. But this is a recognized means of assessing the economic relevance of a country, and even though we are much less strong than the United States and China, we are on par with Germany, UK, and Russia, for example. So we suffer badly with internet-wide attacks. For example, Brazil was hit by over 30 DDoS attacks per hour in 2017. Okay, some of these numbers can be questioned, you know, but Brazil is the 8th largest economy and is the kind of 5th largest victim of a large DDoS attack. So there's something happening here. And also we could mention that, for example, you know, there's been recently a DDoS attack which is based on IoT, which is the first variant of Mirai. And GitHub was recently suffered the highest attack so far, highest DDoS attack so far, and the attack reached 1.35 terabits per second, which is absolutely devastating. Like the second largest was like 2 years ago. And well, I must be careful while mentioning this, but you know, like, this is news the day before yesterday from New York Times, and WhatsApp has been flooded with fake news in our election, which is coming soon. So it's a déjà vu feeling. So we suffer badly with internet-wide attacks, and what happens here affects other places too. And this table represents data compiled from a recent paper, actually published like 2 weeks, 3 weeks ago, in using security. And Brazil is on top of the list. This paper was authored by colleagues at USD. And Brazil is the champion. Is a champion here with over 2,000 rat attacks, remote access Trojans. So we are very good champion on one thing. And And as you can see here, and that's my proposal, it's like having security-related empirical studies of the Brazilian internet ecosystem. So what this map shows, that it comes from Google, is that it relates to IPv6 adoption, and the stronger green colors represent adoption, and Brazil would be green because it's one of the 5 largest adoptions of IPv6. However, it's in red. And why? Because the service provided by servers which have IPv6 is poor. So that's why it's red. So IPv6 is very much present, but it does represent a problem nowadays, and there are security issues also involved with that. So, in sum, what is the proposal for our next call? First of all, to increase impact by performing empirical studies based on the internet. So, unfortunately, this is kind of missing in the Brazilian research community. We don't often see studies conducted based on measurements, on internet measurements. There are a few groups which represent exceptions, but I don't know, for some historical reason, we tend to ignore it. So this would kind of try to solve the problem or to remediate. Secondly, characterize internet-wide attacks, for example, spoofing in DDoS, which I just cited, prefix hijacking, which appeared kind of an exploitation of BGP communities, and this was cited by Italo in the afternoon. Sextortion attacks, which are rampant now, rats, as I cited, ransomware, which hit us last year, and also, of course, the use of defenses accordingly. So, but what makes this unique, would make this unique to a call, would be to focus on the Brazilian internet ecosystem, which we can say is poorly understood nowadays. There's a lot of studies about internet as a whole, and they are all relevant. They are published on IMC, on CCOM, and other security conferences, but not about Brazil. And Brazil is so important, and why we don't see such studies. So we would need to consider local aspects, such as the IXP infrastructure in Brazil is different from Europe and is different from US. It's very different. And the IPv6 adoption is also different. The use of cellular networks and the market and the geolocation, the fact that the people are concentrated on the West Coast and so on. So also language, market laws, corruption, finance crimes, habits, privacy concerns, inequalities, this all affect studies. For example, if you're going to conduct a privacy study in Brazil, you need to consider, for example, the lack of privacy concerns in the Brazilian population in comparison. Or perhaps if you're conducting a phishing study, you need to consider language. Because, or sex scams, you need to consider language, because most people won't understand that message that comes to you saying that they have your password in English, because they won't read in English. They won't understand. My dad won't understand. And so we're missing such studies. And this would be very interesting for two reasons. First, because it has an economic impact, because it can foster like a security market which is specific to Brazil, and of course it can be generalized and affect other markets too, but also because what happens in Brazil affects the US. And so in the global internet, you know, the attackers may be, you know, anywhere, and there are lots of attacks that are being launched from Brazil to other countries, including the US, and vice versa. So that is one idea. The other idea is to improve the security of the programmable network ecosystem. Because anything that is programmable, we know from Dijkstra that it is subject to fault. I mean, we are suffering a lot because of bad software been reading nowadays, and lots of vulnerabilities are there because of programming mistakes. So in the era of programmable data planes and control planes, we have lots of opportunities to make mistakes and create new vulnerabilities to increase the attack space. Time? Yeah, all right, okay, I'm finishing. And so systematically combining this programmable data plane and control planes and systematically is a challenge, and that has not been addressed. And also leveraging software engineering techniques to achieve that with better quality is something. And finally, to try to address more challenging scenarios like SD1s. I mean, not be constrained to a single autonomous system, or at least, okay, but at least a large one, internet service provider, not just a small network. This is one thing. And another is to address critical applications such as avionics and military applications. Which have specific security requirements. So these are the ideas. And one final provocation to the US community is that while we have witnessed several generations of successful European and Brazil joint calls, and just this one now with US, and it seems pretty successful because there were so many proposals, like 55 proposals. No one expected that. I can bet. So that's my wish, that we see more open calls, more collaboration between US and Brazil. Thank you.
Thank you very much. And we agree with you. No questions. We need to proceed. You can make questions offline. Now I'm going to invite Marcelo Damorim from Federal University of Pernambuco.
Hello everyone, my name is Marcelo, so thanks for the introduction. And today I'm going to talk about some of the ideas that resulted from our brainstorming, right? And that's more provocative on the direction of new ideas that can come up on new requests for proposals, right? And just a reminder, right? Our project was on information flow for IoT systems. Right, IoT systems are important, becoming prevalent, and information flows is an important way for monitoring, for enforcing properties on this kind of systems. So I'm gonna talk about some ideas all related to security, but not related to IoT, as I mentioned before. Right. Okay, the first one is about the security for machine learning, and more specifically, I'm gonna focus on autonomous vehicles. Right. I mean, these vehicles use deep neural networks. To decide where to go, whether to stop, whether to move, right, to make a left, to make a right. And as you can imagine, this can be risky, right? And as a matter of fact, some recent research has been shown that someone can trick the algorithms by putting, for example, here, right? This stop sign, the stickers, right, in carefully selected places, and make the algorithm to make the wrong decision.
For example, in these cases, instead of stopping, the car would well, step or step out. I mean the gas pedal, and to set the limit, speed limit to 45 miles per hour, right? I mean this can be really risky, right? So in summary, right? I mean when the human life, I mean, is in play, right? I mean this is an important problem, right? And solutions to this. Solutions to this may require a combination of software and hardware, perhaps I mean co-design of software and hardware. In this particular case, for example, it would require more sensors to make to reduce the noise, right, in these algorithms to make better judgment, right? But I mean this is in summary, this is an important problem that affects human life, right? Okay, so the other problem is about the security for processors, right? I mean, recently, I mean, some problems have been found, right? Some breaches have been found in Intel processors, for example, Spectre, Meltdown, Foreshadow, right? And finding, I mean, analyzing these processors is challenging. It requires knowledge, expertise in different domains, for example, microarchitecture, static analysis, dynamic analysis, and solutions require requires a guarantee on the speed of the processor, right? So this is really challenging, right? And yeah, I mean, there is some ongoing work, I mean, from one of our collaborators on these, I mean, funded by Intel, just important worth to mention, right? Okay, so another one is about the security for microservices. So microservice is an architecture that's becoming more and more popular. So the idea is to break down like a big monolithic system into smaller pieces, and yeah, I mean, which is easier to maintain, to deploy on the network, right? But on the other hand, I mean, you increase the attack surface, right? I mean, some of these microservices need to communicate with each other, and while before, right? I mean, these would be like function calls, right? I mean, after that, I mean, you'd have, I mean, intercommunication, right? I mean, really network communication, potential risks for attacks, right, of adversaries. And the idea here is to build practical techniques for analyzing these microservices, and this includes testing these containers, right? I mean, troubleshooting them once, I mean, the problems have been found, right? And minimize containers to reduce the attack surface, right? When I mention containers here, I mean, typically these run on a tool called Docker, right? Which encapsulate, I mean, all these runtime environments, right? Okay, and finally, I mean, this was added last minute, right? But still, I mean, we discussed that, and the idea here is to test, I mean, new network architectures, right? And new internet architectures, and leveraging some of the test bed that already exists. I mean, there's the idea is not, I mean, to propose, I mean, new test beds for that, and I mean, we use, I mean, test beds like Dether and Fiber that people have been using for a while, right? So all in all, I mean, this is some of the ideas that we believe that could be promising, right, in this domain, right, in security on different areas. Okay.
Okay, thank you very much. Now I would like to invite Professor Michele Nogueira from Federal University of Paraná.
Thank you, Anderson. So you asked one slide with topic. I put this analytics for wireless network and device fingerprinting, so you can note. I want to just remember the analysis that we did some years ago about the big challenges for security in Brazil. And Professor Dahab and myself, we came up with these main topics for the security community in Brazil. So now I will specifically focus on network security services and cyber physical and cyber human systems. One point that we know and was raised here for, I think Marinho talked about Italo before, about the spoofing. So this is a critical problem. And in general, what we see is that in the literature, they target the point of the problem of the spoofing, or mainly in the network layer. So how address the IP spoofing and things like that. Another point also is the characterization of the traffic. We know already that we can have information, we can extract information from the traffic on the network. So we can, by the time of arrival of the package, we can see which application is coming, or we can do this kind of analysis. But it's not complete. So one point that we should investigate more is the relation of the hardware and the spoofing thing, and also the analysis of these characteristics related with the analysis of the features that we have. So what we propose is try to investigate this kind of problem to avoid this spoofing in terms of IP or even in other layers of the protocol stack. In general, as I mentioned before, we work only one layer. Here, we could address or try to investigate cross-layer approach that can first of all, try to understand what happens or what the attackers can do to characterize those kind of behaviors, focus on physical network or other layers, and also how to address this after this first phase of the research that we can do. So this is a very specific proposal. Last November I presented was a little broader, but now I try to focus more on that sense. So what could be the benefits for both Brazil and other European community or US? Well, in this kind of work, we could combine different communities, like wireless communication, security, and machine learning, for instance. We could create and collaborate with the community with data repositories and this characterization of the behavior and the features in the network. Of course, this could lead for multiple citations and bootstrap our research and their research too. And we know that it's important for the security community, both in US and in Brazil or Europe, this kind of research here. So some suggestions is to focus on the design of systems, hands-on, try to have and to create this experimental and demonstration system, kind of prototype those systems itself. We could also create demonstration days during the PI meetings and video channels, etc. Also, this could help to an extensive dissemination of this key research results, and also encourage the joint IP or the intellectual property that is basically on the design of the systems. So this is what I have. Thank you.
Thank you very much. Well, now I'd like to call Edmundo Souza. From Federal University of Rio de Janeiro.
Okay, we decided to do a two-way presentation with people, so I'm gonna talk very fast, as you noticed, then Belém talk and the Professor Tosley. So that will be a short presentation. Okay, I have problems here. No, that's not it. That's not it. No. No, that's not the slides. Okay, I think we need to change slides here.
Can we maybe change for Michelle Vangham, and then when Professor Edmundo is ready, we start with Professor Edmundo. So please, Professor Michelle Vangham from Univali.
Good afternoon. I'm a professor at University of Vale do Itajaí. Thanks for the invitation to participate in this panel. Before suggesting areas or topic for future joint calls, I'd like to suggest that the joint calls focus on applied security. In other words, I would like to suggest that the joint calls encourage the transition of promised research ideas into practice. We have several application domains in which security and privacy by design are essential requirements for the application effectiveness, but also important to required by law. In IoT, considering IoT areas, we have several application domains. I suggested 4. Aligned with the UN SDGs and aligned with the Brazilian Strategic Action Plan for the Internet of Things. These are Smart City, Health, Smart Farming, and Industry 4.0. My interest research topic is applied identity management or identity access management. Identity management can be defined as a set of processes, technologies, and policies used to assure identity information, for example, identifiers, attributes, credentials, used to assure identity of an entity, users, devices, and system, used to provide authentication, authorization, and accountability, and finally to safeguard privacy. In order to develop authentication, authorization, accountability infrastructure, we need to consider application domains features such as heterogeneous device with different manufacturers, with different protocols, IoT technologies, and with different security administrative domains. Usually via wireless communications and sometimes using constrained devices. Federated identity management model is suitable for this scenario, multiple security domains and Internet of Things. And this model could be combined with a user-centric approach to safeguard privacy. A significant challenge is to develop an innovative identity management solution that is suitable for specific IoT applications. Identity management system for IoT should cover the entire user and device identity lifecycle, an appropriate identity provider for Internet of Things, which is responsible for user and lightweight device authentication, Identity management system should cover strong authentication, though with high usability, attribute-based access control, since it is aligned with the federated identity model and IoT, fine-grained access control, in a flexible and dynamic manner, consider context-sensitive and adaptive approach. Blockchain-based solution to build trust relationships between entities and devices and to contribute to accountability. And finally, interoperability between identity management systems. For instance, SAML and OpenID Connect and certificate-based solutions. As I have recently suggested, the joint calls should focus on taking account applied security. Therefore, experimental evaluation is an important part of this process and should consider applicability. It considers different case studies, performance, security and resilience, usability, scalability, interoperability, and legal conformity. So, thus, a test bed is very important to this kind of experimental evaluation. So, a test bed is for security experimental evaluation, it's necessary. And thank you.
5 minutes.
Thank you very much. So now, Professor Edmundo, please.
Let's try again.
That's right.
Okay, now it's correct. So the first we decided to do a pitch, but more broad, not only relate to security. But if you want to match to security, you find that. So the first, that's a set of topics I like to propose. And in fact, it was very nice that people talked before. Professor Marinho, we are very much in line what we decide. So the proposal will be data analytics in computer networks as a overall topic, and that creates points to several bullets. For instance, we can have network security, like detecting attacks. So in the wild, so that needs experimentation, that requires monitoring and analysis data. So in our project we are doing that part, and Marinho mentions pretty much that that's an important issue here in Brazil. So totally agree. And so those topics in data analytics, how do you analyze it fits very well what he said. I'm going to skip that and talk a performance evaluation after that. So you require to use data analytics and measurements to try to do networking planning and other issues that are also have been very much updating in performance evaluation. Cache. There has been a lot of research in cache and network lately in the last several years, and recent work also has addressed data analytics or results from monitoring and analysis to enhance cache networks. And finally, has been many people mentioned that IoT and everything is related. So this set of topics you can match to security only, or most of them to security only, but also in a network in a broader sense, and all in this data analytics umbrella. Okay, so now I am gonna switch to Belém.
Well, self-driven network the idea is they are advanced in artificial intelligence possibility as create economically feasible self-driven networks. So self-driven, I have just to not forgot here. Come on. Well, okay. Self-driven networks use self-configure, monitor, management, correct, defend, and analyze all with very little human intervention. So the idea, in fact, we have a lot of challenges here to permit this kind of networks, and I think it's a great topic to call.
Okay, so again, I didn't stick to security, and I just wanted to put a plug in for, I guess, a research area that I've been getting into, which has to do with quantum networks, and namely multi-user quantum networks. Now, why is that sort of interesting now? It's because there are a number of companies that have built small quantum computers, but it looks like it's going to be a long time before they're going to be able to build large quantum computers. And so the only way they're going to really be able to sort of harness the power is if they have some way of connecting them. And so they're, to me, that makes it a really very interesting research topic, namely, you know, how do you build a quantum network? What should it look like? What's the right architecture? What are the right set of protocols? There seem to be a couple of applications. One, as I said, has to do with distributed quantum computing. The other is that there are apparently a lot of sensing applications that would benefit tremendously by connecting sensors at large geographic distances, again through a network. And there's, I guess, question about whether you would use the same network or would you need different networks. It turns out that there are at least two approaches that have been sort of proposed for quantum networks, both of which are very, very different from each other, although both of them ultimately can deliver the same kind of services, entanglement networks and qubit communication networks. And so there's really a very interesting question about what's the right way to do that. There's a question, let's say you start to do this, how do you integrate it with the internet? And it's sort of envisioned that a quantum network is going to have a classical control plane, but a quantum data plane. And it's not at all clear about how you would sort of synchronize the two and at the same time separate them so they don't get in each other's way. There's a question related to, you know, how do you go about evaluating performance of these kinds of networks? What's the right way to do simulation? What's the right, let's say, mathematical modeling paradigm for it? How would you go about doing measurements? What kind of measurements would you need? And then I just put one last topic having to do with resource allocation. This is supposed to be a quantum network that will serve lots of users, and so then you have to worry about allocating the resources among them. Okay?
Okay, thank you. Last but not least, I would like to invite Professor Fetzer, Christoph Fetzer from Technischen Universität Dresden. He's not going to use any slide.
Hello. No, I'm not using any slides. I'm completely unprepared, like always. But I have a pitch anyhow. So my pitch would be trusted IoT. So IoT, we all know it's a huge market. There are lots of interesting problems to address. So some of the other speakers also mentioned IoT. And what do I think are the challenges in IoT? So one thing, of course, is privacy. We have all these IoT devices at home. They can listen to us. They can videotape us. They can do all kinds of things that we don't typically want. And the problem is that we cannot have privacy without security. And there is a fundamental problem there because security will always be broken in IoT in the way the business model works, because if I am an IoT device manufacturer, I produce that device, I will have some software on it, and I will not maintain that software because you should buy a new device before to get the newest software update. At least that's the way how it works right now. And that means I, as an attacker, have a really easy time to attack your devices because I just look at the bugs that will be discovered in the next years, and then I attack your old software and I get access to your data, because you will not replace that IoT device in the next 5 years because it costs you money. So what we need is kind of something forward security for IoT devices. I think we have to deal with software bugs, and I believe there are some solutions in the future because there will be strong security on the IoT processors, because Moore's law is not yet at its end for IoT devices. It might be at its end for server processors, but we will expect more more features for the IoT processors, and there are some chances that we can address that issue. So therefore I pitch, say, trusted IoT. There are lots of interesting choices, and it would help society to have more privacy in our homes. Thank you very much.
Okay, thank you very much, Professor. Well, so we come to the end of this workshop. Well, we need to thank NSF for coming from the United States, and all the PIs, American PIs, who come here, and also faculty from Europe. Also, thanks for the Brazilian coordinators and Brazilian participants. It's always good to have the students. We have the security community here, and it's very good. So yeah, I'm very happy with the result of this workshop. I hope we're going to have the same workshop next year, but that will be in the United States. We're trying to do kind of once in Brazil, once in the United States, just like we do with the European Union. So thank you very much for your presence, and that's it. Thank you very much.